So it's just we're saying that if you're looking at a coil from one side and it looks like that, the direction of the current looks like that, and then it goes into the screen, you get other coils, you got other wires going into the screen. But if it's going in that direction, then that's similar to the north, because it's going in the same direction, and the N is a good reminder of that. So that would be the North Pole, and if you looked at another one and the direction was like this, then that looks more like a south, right? So that would be the South Pole of the solenoid. And there's also this idea of something called a magnetically soft material, and magnetically soft materials magnetize and demagnetize really easily. So another idea that I wanted to talk about was this soft magnetic materials and hard. Magnetic materials. A soft magnetic material could be, an example would be iron, and a hard magnetic material, an example would be steel. So a hard magnet, for example, like steel, it means that once you magnetize it, it takes a lot of work to then demagnetize it. So these are very good to make permanent magnets. So hard magnetic materials are good for making permanent magnets, whilst iron and soft magnetic materials, they're easy to then demagnetize. So the magnetization can even change. You can turn it on and turn it off, and much more malleable like that. So then we make electromagnets with things like iron, electromagnets. Okay, so that hopefully that makes sense, the difference between soft magnetic and hard magnetic materials. But they're both got these domains and ferromagnetic. So what else? One more thing about solenoids is that if you want to increase the effect that this solenoid has, or the strength of the magnetic field that you produce, then one thing you can do is to insert a soft iron core, soft because of this idea that I was just talking about right now, instead of hard, in the middle of the coil. So if you chuck an iron core here in the middle, of soft iron, then it increases the effect of this magnetic field, because of the domains and all the atoms and all the alignment of the spins of the electrons in here in the iron. They amplify the effect of this, and then this whole thing, once it's got a soft iron core in the middle, that would be called an electromagnet. An electromagnet. So magnetically soft materials such as this iron here, it magnetizes and demagnetizes very easily. As soon as you turn off the current through the solenoid, so this current of the blue wire going around, in this direction it's going in this case, as soon as you turn it off, the magnetic field disappears, and the iron doesn't stay magnetized in this case. So that's very, very useful about soft iron. You can use it in this way, and then you can really control what magnetic field is doing, and that's really useful for lots of applications. We'll talk about them later.